All right, boys and girls, we're going to talk about a new skill today. This is kind of a little bit of a change from what you guys have been working on lately, which has been multiplying and dividing decimals. Um, we are going to pretty much start our fractions unit, which starts with a skill that most of you will probably be pretty good at as long as you know your multiplication facts. And even though this math that I'm showing today and the math that you might be doing over the next week or so doesn't really look a lot like fractions, believe me, it plays a huge role when it comes to fractions and how we use them in fifth grade. And so the skill that I'm referring to today is factoring and being able to factor a number. And I've put the definition here on the side. It says factors, these are numbers that are multiplied together to get a product. And so the way I usually show my students is it kind of will kind of remind you of a T-chart. Your teachers might show you a specific way they want you doing it. This is kind of how I want my students doing it. But when you're factoring a number, you're thinking about, okay, well, what times what will give you that number? And so on this first example, I have the number 18. And so really, it's not too difficult as long as you know your math facts. You're kind of starting off going, okay, well, what times what will give you 18? So a lot of times what's going to happen is if you really know your math facts, one of the first things that might pop into your head is a math fact. Like I'm going to throw out one that gives me 18, which is 3 times 6, which is good. Those are definitely factors. But what I'm going to strongly suggest doing is when you're factoring numbers, you always start with what I usually call the universal factor, and that is 1. 1 goes into every number. 1 goes into everything. And you guys should know that rule by now. 1 times itself is going to give you that number. So when I'm writing these out or I'm factoring with my students, I always start with 1. And there's a reason behind that. We're going to talk about it here in a second. So I'm going to write 1 times 18. Okay, so the reason why that's important to start with it is really and truly when you're factoring, it's good to go in order. And what I mean by order is you kind of start with the lowest factor and you work your way up. And so you'll see it towards the end of this when we're done, but it's kind of like this. Okay, I'm going to start with 1. 1 goes into everything, so you know you're always going to write 1, but your next thought should be, okay, well, does 2 go in? And again, if you know your facts, you know 2 will go into 18 because it's a math fact. So I'm going to write that next one, which is going to be 2 times 9. All right, and then again, it's a pattern. You're thinking, okay, well, 1 goes in, 2 goes in. Does 3 go in? And of course, yes, it does. 3 times 6 is the one we talked about earlier. And so 3 times 6 is one that we're going to write. And then now it's kind of like, okay, well, I could start thinking about other numbers. But really and truly, this is kind of what I tell my students is when you're starting your writing them out, and you're going in order, you're probably in the back of your mind thinking, okay, hey, 18's a low enough number. I don't know if there's any more multiplication facts that give me 18. I've got 1 times 18, I've got 2 times 9, I've got 3 times 6. I could keep testing. I mean, I could go up to a 4, but if I know my 4s, which everybody should, I can't multiply anything times 4 and get 18. Well, my next one would be 5, and I know 5s don't work, and then I can go to, the next one, which would be a 6, which I already have. So this kind of brings me to my next point. There's 2 things I really want you to watch for here on this. So the first one is a common error or a misconception, and that is you never want to double dip factors. And what I mean by that is when you're writing these out, you don't want to write them out and go, oh, okay, well, I know another one. I always get this, well, oh, Mr. McClure, I know another one. And it's a kid might look at this list here and go, well, what about 6 times 3? Well, 3 times 6 and 6 times 3 are the same fact. And so I don't want to double them up. I don't want to write them twice. And so really and truly on this particular one, I actually think I'm done. And here's the reason why I know I'm done. And this is really important. And this is a great tool because when I first started teaching, I didn't know this tool. And then I learned it from Miss McDowell, and I thought, wow, that's really cool because I never knew that. When I was a student, I thought, oh, okay, hey, I'm learning how to factor numbers. And factoring wasn't too bad because I really knew my math facts. But when I learned this, I was like, oh, man, that's really cool that I now know that. But I didn't learn it until I was a teacher, so you guys can learn it when you're students. So the trick is when you're factoring out numbers, so you've got 1 times 18, you got 2 times 9, you got 3 times 6. If you're going in order, it's kind of like this. Well, we tried 1, it worked. We tried 2, it worked. We tried 3, it worked. The next one we would try would be 4. Okay, it didn't work. The next one we would try would be 5. It didn't work. But the next one we would test would be 6. And here's the trick. When you're testing them in order, if the next one in line shows up on the right side. So I'm going to kind of look at this as, okay, I've got some numbers on the left, I got some numbers on the right. If the ones that you are testing, if the next one shows up on the right side, which is 6, which it does, you know that you are finished factoring. So there's kind of an old method here, and it's, some of you might know it, and that is when you're factoring, you could think of it as like a horseshoe. And if you know what a horseshoe obviously is in the shape of a U, but basically you're kind of going in that motion, you're going in that direction. It's kind of like this. I started with 1, I started with 2, I started with 3, 4 didn't work, 5 didn't work, but then over on the other side, 6 was already there, and since I'm not double dipping, I'm not repeating, that I know I am finished factoring. I'm done factoring the number 18. So let's talk about a few things that are important when it comes to factoring. Sometimes you might have a question where it just simply asks you, how many factors does this number have? Well, if we're factoring 18, all we're going to do is we're just going to count the numbers that we see. So I'm going to circle them. I have 1, I have 18, 2, 9, 3, and 6. So I know that 18 has 6 factors. All right, pretty simple, not too hard. I know those other, it's kind of like this. Sometimes kids will overwork themselves. Sometimes kids are like, oh, okay, well, let me try 10. Does 10 work? Well, 10's not going to work because if you know your facts of 10, you know you're always going to have a 0 in it, which 18 does not. But it's kind of one of those things where if you're, I always tell my kids, you want to work smarter, not harder. This would be the case where, hey, if you know that horseshoe trick, you know you were done. There is nothing else that you can multiply together that gives you 18. A popular question that sometimes will come up in my class, at least in the past, is, well, what about decimals? We do a lot with decimals in 5th grade. Can decimals show up here? The answer to that is no. Decimals will not show up here. In my years of teaching 5th grade math, when you are factoring out numbers, you're not going to see decimals show up as what's called a factor, or sometimes called a factor pair. And so I don't, that's one of those things. It's a good thought. I like when kids ask that question because they're definitely thinking about things that we've done in class, but you're not going to see decimals when it comes to factoring. Okay, let's talk about something else that could pop up. And I said it a second ago. It's something what's called a factor pair. So a factor pair basically is when you think about the word pair, you're thinking about 2. And, think about like a pair of shoes. So you're thinking about the number 2, and basically all you're doing is you're thinking about the groups of 2s that you had. So like 1 times 18, that's a factor pair. And 2 times 9, that's a factor pair. And 3 times 6 is a factor pair. So on this, if I wanted to answer, okay, well, how many factor pairs does 18 have? Then I'm thinking, okay, well, it has 3. And I always tell kids, well, think of it like, okay, if I have 6 factors, usually, most of the time, it's just going to be half of whatever that is. So if I'm thinking about factor pairs, half of 6 is 3, so that's how many factor pairs I have for 18. So it's a pretty easy skill, and I'll always tell my students when this pops up this time of year, you really have to be good at multiplication facts. All right, let's practice factoring 32. So 32 is, and let's kind of start with this. Sometimes when you think about factoring, you might be thinking, okay, well, how can this get more difficult? Well, most of the time, if it's going to be harder on a student, the number's going to go up. It's going to be a bigger number that maybe you aren't as familiar with. It's just a little bit harder number to deal with. It's not as friendly. So that's really how it gets harder for most students. But honestly, it still goes back to math facts. If you know your math facts, this is going to be still pretty easy. So watch what happens on this one. So I'm going to factor 32, and I'm going to go a little bit faster here. So I'm going to start thinking, okay, well, 1 times 32, obviously, that's going to be the one that always works. You always want to start with 1. The next thing that would happen on this particular one would be, okay, let's think. If I start with 1, I know my next one has to be 2 if 2 is going to work. Well, this is the discussion I would have with my students. I know 2 is going to go in because 32 is an even number. And every even number on the number line, 2 is going to go into it. So I know 2 times something gives me 32. Well, let's kind of stop and think about this. So you shouldn't know, it's kind of like this. It's not a math fact. 2 times something equals 32. It's not a math fact. When you learn your math facts and you memorize those math facts, technically this is not a math fact. But by 5th grade, you ought to have the skills to go, okay, wait. If I don't know how many times 2 could go into 32, I need to know how to go get that. So one of the strategies when you factor is, if you get stuck, is to do the opposite of multiplication, which basically is division. So I'm going to write this out to the side just to prove this is what would happen if you didn't know. If you don't know, you've got to go show some work. You got to go prove your answer, basically. And so at this point, I know 2 is going to go in. I don't know how much it's going to go in, but I have to prove it. So my math would look like this. Okay, so 2 can go into 3 one time. It's going to go underneath. I'm going to subtract. I'm going to have 1 left over. I'm going to compare, and I'm going to bring down. And at that point, it's kind of like, okay, well, all right, I think this is going to go in equally. So the whole, 2 going into an even number, it's going to be true here. How many times can 2 go into 12? Well, that's going to be 6. There's not going to be any remainders or anything left over. So I know 2 times 16 is going to give me 32. Okay, so I know there's going to be some kids out there that are going to go, well, hey, I knew that already. I didn't have to go and divide. And you know what? That's fine. If you know that and you have pretty good number sense and you can do that mentally, then at least I tell my students, I don't mind that. But there are going to be some times that you might have to go test it out and see. And you can't get lazy. You got to show your work. And so in this case, I think I knew that 16 was going to be it. But hey, at least I have the work there to prove it. And it's like I tell my students sometimes, you don't want to guess. Guessing is no good. You want skill. Your skill there is solving it, going and showing your division problem. And again, it's that good feeling. It's that gut feeling of going, okay, hey, I got it right. When you guess at something, you don't have a good feeling in your stomach. But when you show your work, you do. And you're like, oh, sweet, I got it. Guessing is not going to get that done. You're going to be kind of uncertain. Well, maybe I got it right. You don't want to guess. So make sure you show your work and make sure that you're taking some time to do it. Okay. So the next one would be 3. Okay, well, let's think about 3s. So I'm just going to write a 3 here. I'm not going to say 3 is going to work. I'm just going to write a 3, and I'm going to think about my 3s. So sometimes when I'm doing this in class with my students, our strategy could be showing your work out to the side like I just did, or sometimes it could just be, hey, let's think about math facts here. So I would probably at this point go, okay, let's think about my 3s. The biggest 3 you should know and have memorized is 3 times 12. And so if you have those memorized and you know them, then I don't think that's going to give you 32. Because if you do 12 times 3, that gives you 36. You can even back up one fact and do 11. Well, 11 times 3 gives you 33. That's not 32. So at this point, I might be going, okay, hey, you know what? I did some testing. My testing didn't work, but it was because I knew my math facts. And if you know your facts, I'm good with that. Okay, so 3 is not going to work. So my next one's going to be 4. Now, when I see 4, again, I'm going to think math facts. Now, I think this one is going to work if you know your facts. 4 times 8 gives you 32. It's always 32. It never changes. Don't forget that. That's always a tricky one. Memorize it. All right, the next one's 5. Okay, I'd go back to math facts. I'd probably ask my students, okay, what is your fact of 5 that gets you close to 32? Most of them that know their facts would probably say 6. Well, 5 times 6 is 30. All right, well, 7 times 5 is 35. Nothing gives me 32. So I've tried 5, 6, same thing. You could test out some 6s. 6s can't go into 32. 7s can't go into 32. My next one to test would be 8. But look, 8's on the right side. So if I'm doing that horseshoe method, then I know, hey, I'm finished. Because the next one I'd have to test showed up on the right side. And so at this point, I would stop and go, okay, hey, I've factored 32. I have 1 times 32. I have 2 times 16. I have 4 times 8. But there's nothing else that would work. There's no other math fact. There's no other number that gives me 32. So I'm just going to label some things here. I'm going to say that it has 6 factors. And then I'm going to say that it has 3 factor pairs. And honestly, I don't know that you're going to see those things pop up a lot in 5th grade, but I think it's still good to know it. And, again, it's just math language. You need to know what you're doing. You need to know that you are finding 6 factors and you're finding 3 factor pairs. You just never know. It might pop up. All right, so a lot of this skill here really revolves around multiplication facts and knowing your facts and being able to, memorize those facts and get those facts down. Because, man, if you have that, I always like teaching this every year when it pops up because I remember as a kid, this was easy for me because I knew my facts. And I could go back to that and I could just share it now with my students. And it's like, gosh, if you want this to be easy, learn those math facts.